Hey, mathematical geniuses. Today we're going to talk about properties of congruent triangles. Now, let's first talk about what the word congruent means. Congruent means the same. They are completely equal. There's absolutely no difference between the two things. Okay, and with triangles, we don't need to know all three sides and all three angles to be able to say the two triangles are congruent. We only need to know a certain amount of those things and in a certain combination. And that's what we want to talk about today. It's pretty simple once you remember kind of the ways we can test for congruency. There is one that kids always say is a way, and it's not a way. And we'll talk about that one in a minute. But that's the one just to be careful about. Okay. All right. So there are minimum sets. I'm just going to hide my face here for a sec. There are minimum sets of angle and side measurements that, if known, allow you to conclude that two triangles, are congruent. We will go through the three most common ones together. Okay, the three most common ones together. Well, here's the first one. If three pairs of corresponding sides are equal, then the triangles are congruent. This is known as side-side-side congruence, or SSS. Okay, so in the diagram here, just let me get my ink going. In the diagram here, we have AB equals XY. So AB equals XY. Those lines correspond to each other. They're exactly the same. Okay, then we have BC equals YX. So BC equals YX. And I want you to notice that this one had 3 tick marks and 3 tick marks. This one had 2 tick marks and 2 tick marks. So that's our way of saying those are the same. Okay. Finally, I have AC is the same as XY. Okay. Well, think of 3 toothpicks for a second. Okay. If I had 3 toothpicks that all had different lengths and I asked you to make a triangle, there is only one triangle that you can make, right? You have to just connect the edges of the toothpicks together, and that's the only triangle that you can make. And so there's only one triangle that can come out of that length, and that length. Okay, so if both triangles have those same lengths, then they have to be the same triangle. They have to be congruent to each other. So we say triangle ABC is congruent. This symbol here with an equal sign and a little wave on top, a little piece of bacon frying in the frying pan. That means it's congruent to, okay? So that guy there means is congruent to. Now, the other thing while we're talking about this, the order matters. It tells us who is corresponding. So if I showed you the fact that this says ABC equals XYZ, that tells me that A corresponds to X. Angle A and angle X are the same. B corresponds to Y. C corresponds to Z. Okay, so the order is always very, very important when you do these things. As well, it would tell me that length AB is the same as length XY, or length BC is the same as length YZ, or length AC is the same as length XY. Okay, so you can get all that information just based on the fact that those corresponding angles, when I label the triangle, are always written in the same order. Okay, all right. The next test, let me hide myself for a second here. If 2 pairs of corresponding sides and the contained angle are equal, then the triangles are congruent. This is known as side angle side congruence, or SAS. Now, the fact that we say SAS is important. What that's saying is that the contained angle, sorry, I'm just getting my ink on here. The contained angle has to be in between the two known sides. So essentially it's like this. If I know this side and I know this side and I've locked this angle in place, well, what I want you to notice there is now only one way to make a triangle, and it's just to connect this piece and this piece together. So if those two sides with the angle in between are known, and they're the same on two different triangles, then those triangles have to be congruent. So we said AB equals XY, angle B equals angle Y, and BC equals YZ. That is enough information with SAS congruency to say, therefore, that's what that little symbol here means. I don't know if anybody ever told you that. That means therefore. Therefore, triangle ABC is congruent to triangle XYZ. Okay. And then the third way we do this, I'll just hide myself again for a sec. If two pairs of corresponding angles and the contained side are equal. So this is kind of the opposite of what I just said. I have two angles and the side in between. Then the triangles will be congruent. This is known as angle side angle congruence, or ASA. Okay, again, the way we write that is important. ASA, the S implies that the side is in between the two angles. So think of it this way, okay? Let me get the ink going again. If I know this guy, okay, and then I say, okay, from that guy, I want to branch off in that angle, and I want to branch off at that angle, you can see there's only one way to get the triangle, and it's where those two branching off pieces meet. I can't change this triangle to any other dimension than what I've got based on this bottom side and these two locked angles. Okay, so ASA is also a test for congruence between two triangles. So angle B equals angle Y. That would be these guys here, just to make sure everybody's on the same page. Angle B equals angle Y. Okay, then we're told BC equals Y Z, so that's this line right here. And then we're told that angle C equals angle Z. Okay, so that also will determine congruency for me. All right, so all you're doing today is actually looking at pairs of triangles and trying to figure out if they have congruency or not. Now, there's two quick little things I want to warn you about. One will test for congruency and one won't, okay? So let me just draw those for you. If I had a right triangle where I know this, I know that that's 90 degrees, okay? And say I know that this was 3 and this was 5, okay? Now, this is not a scenario that I gave you. Like this is not SSS, this is not ASA, this is not SAS. But there's a relationship with a right triangle called the Pythagorean theorem. If you had this, you automatically know what this bottom side is because of the Pythagorean theorem. So that would actually give you SSS congruency if you had two triangles that had that 90 degree, the 3 and the 5, okay? The other conversation I want to have with you right quick is if you had a triangle and you knew all three angles, you knew this guy, you knew this guy, well, let's not say they equal each other. So you knew this guy and you knew this guy and you knew this guy, okay? And you had that on two different triangles. So then you had this guy and this guy and this guy. You can't say that those triangles are congruent. All you can say is that they are enlargements or reductions of each other. They're similar, but they're not congruent. So AAA, all three angles known, is not a test for congruency, okay? You want to be careful of that. All right, my friends. So your homework is right here for you. If you are one of my kids at school, go through this, make sure you're explaining your thoughts, and make sure you're asking me lots of questions, okay? You got this. Take care.